Hi everyone, my name is Amrit and I'll be showing you my algorithm that I have implemented neural network to predict numbers, handwritten numbers from images into text values. Okay, before I begin, I would like to point out that there are many algorithms which can do the same thing. The first one is a logistical regression algorithm, which does the same thing, the task of detecting the algorithm. As you can see, the training set accuracy is 95.1%. That means out of all the training set data that I have given it, it has predicted 95 of them accurately, 95% of them accurately. Okay, and now I'd like to show you the neural network. Uh, okay, so first of all, we'll see the data, the, how the data is. The data is a 20 by 20 pixel images like this one right here, and the pixels intensity are mapped to a matrix of 400. Means 20 by 20 matrix, that means matrix has 400 elements in it, and every element is a pixel intensity. Okay, so the first pixel intensity, and this is in grayscale, so that means the values are between 0 to 255. So that's how these are like mapped. The second thing that you need to understand is that that is a data set. Okay, and second thing is the data inside it, that is 8, has already been provided. So the computer actually uses this data, these all data, about 5,000 of them, to scan and then learn. Like, it learns that okay, for a pixel intensity value, a pattern of pixel intensity value like this has a corresponding element of 8. The next image then has 0, then 3. So it teaches itself that for this type of pixel intensity pattern, the value is this. Okay, so after that it has learned for about enough examples. I give it a image and then let it predict what the value of that image is. Okay, the values are then picked from randomly from a set of another images, and the output is given here in the console screen. So let's see. First of all, as you can see, the training set accuracy is 97%, which is more than the accuracy of logistical regression of 95%. Plus this is much better, much efficient algorithm at predicting. Okay, so let's go. The first image that we will try to predict is 4, as you can see. Okay, let's see the computer if the computer can predict it's 4. Yeah, it predicts, see, digit 4. Next, it's 8. See if it can predict. Yeah, it can predict. Next is 9. Okay, very good. 6, awesome. 3, yeah, and 6, yes. 0. Now the 0 is mapped to a value of 10, because in Octave the indexing is from 1, not 0, like in most of the programming languages. So it's 10, but I will request you to see this digit form which predicts 0. Okay, so the digit is 0. Next is 4, so it predicts 4. Next is, I don't know, it's 6, it's 2, so it predicts 2. So as you can see, it's really good at predicting the values of the images. Okay, for those of you who are more like who want to know the technical details of the algorithm, the algorithm has takes x, the number of inputs is around 5,000. So this takes about 5,000 value. It's a matrix, so it does not really depend how many how many images I give it. It can scale properly. Second is the number of the hidden layer that does all the neat stuff, magical stuff. So it has 25 number of units plus a bias unit of 1, so that's make it 26. 26 unit of hidden layer. Every neuron, there are 26 unit of neural network in the hidden layer, and then the output layer has 10 units. That means for every one number there is 1 unit. So if the value is 1, the first unit predicts 1 and rest of them predicts numbers. So the first unit predicts the highest value and everyone else predicts the lowest value. So I just calculate the maximum value that is being predicted, and then according to its index prints the value of the number. Okay, simple as that. Another thing to understand is that this algorithm is scalable. So right now it's only predicting between 1 to 0. I can also give it values. Just I have to only like take out the images of A, B, C, D, E, M, C, H and give it enough images to uh, recognize like anything. I can train it to recognize faces, or use the same algorithm with a camera in the street, and it can record number of cars passing by, number of humans, and so on. One great use of this algorithm would be reading the CAPTCHA images. Okay, so that's how it works. So thank you for watching.